Okay, anatomy of a vector. So a vector is, well, you just watched the clip. I'm not going to play it on the video here, but the clip about Vector the superhero. What did he have? He had his crimes would have magnitude, not velocity. Velocity can be a vector, but it has magnitude and it has what? Direction. Okay. So this is obviously heading in this direction, and that is heading in that direction. Would you agree? Except they're the same direction. You were supposed to correct me. They're the same direction. I'll prove it. Look at that. They are special. There's a special relationship between those two. They're equal because they have the same magnitude and what do you think? Same direction. Okay, good. So those have the same magnitude and same direction, and they are equal. So we can call it A, B, as in kind of like back in the old days when you'd name a ray, but this is not a ray. It should be called A, B, with a little arrow that only has 1/2 of the point on it, because math is kind of picky that way. We don't want to just say, oh, well, this time that's not a ray. This time it's a vector. It has to be a different symbol. And so unfortunately, the smartboard isn't written that way because the tools that we get with this like software don't allow a vector symbol. Superheroes would be really annoyed if their symbol wasn't even allowed. There it is. That's how it should be written. How about the A? Same thing, just a little line over it. So you can call it just one letter. You can call it 2 letters. Just don't call it what? What's a common thing that people would call it? Not, yeah, I don't even mean the ray thing. It's not a line either, that's for sure. Come on, you can do this. What's it? Yes, BA. And that's not because it's a bad something. It's because AB has a direction. BA, not behave, that's completely different too, has an opposite direction. Do you get when you say the letters in a certain way, you're implying a direction? You are with vectors. Because vectors, it's all about direction and magnitude. So you would say AB, but you would not say BA. Okay, and there is, vectors can be equal to each other, as in we just described that, but how about a 0 vector? It's weird, but it won't make any sense for me to draw a 0 vector because it has no magnitude and it has no direction, which like refutes the whole point of what's a vector. It has to have magnitude and direction, but the 0 vector can't have either, really, if you think about it. So they cheat and they say its magnitude is 0. It has a magnitude, it's just that the magnitude is 0. Okay, and they say it has a direction. It has every direction. I know, that's cheating. It's just cheating. So here is one that would have a couple of vectors that are being added. Actually, I got a nice slide for that. Not this one, that one. Addition of vectors. Would you please get used to drawing over the top of these and then grabbing with your little lasso tool to drag it over? Because I'm going to add A and B right now. And I'm going to move them so that they'll like match up nicer here. And I can just grab and move my vectors around. You can't. So what you're going to have to do is like take your marker and draw on it. And then you can use your little lasso tool to grab it and then move it. You get what I'm saying? Okay. So I'm going to be doing it this other way though, because I can, because my software is neat that way. I wish you guys could. I wish they had movable things in PDFs like that. That would be really cool for our iPads. But anyway, that's A being added to B. You just put the head to the tail. Can you guess which end's called the head end? The arrow end. Yep. Think of it like a snake. The snake has a really pointy like wedge head like that, right? So it's like 2 snakes that are like chasing each other here. The A is chasing the B. So that's A plus B. Now think about it for a second. Do you get how that sort of can make a triangle? Do you get that in the end you started here and you ended here? Would there have been another way to represent that? That is how we represent the answer to those 2 vectors being added. And that is the result, right? So they have a neato name for it. You've probably never said this word before. Think about that. I've said an awful lot of words over a lot of time. Resultant. Now he said it. First time in his life. I got to see it. Isn't that special? Resultant. Say it. All right, good. The resultant is this red thing right here, okay? That is the answer. And how do we say it? We say it's a plus b, but we don't just say it's a plus b because really that wouldn't make any sense, would it? I mean, really, can you get that distance by adding those two numbers together? I mean, if this is 5 and this is 7, that can't be 12. It can't be. That's because if they were like laid end to end like this, 5 and 7 could make 12. But if they're in any kind of an angle to each other, then it can't be. It could be the square root of 7 squared plus 5 squared, right? Because if this was a right triangle, do you get how you could do, you know, the Pythagorean theorem to it? So moral of the story, we don't just say it's A, B like that. We put bars around it, and I hate when they do this. That is something that is already used. It looks like absolute value bars. They're not. They're saying the resultant vector is A plus B. Do you get if we actually had numbers and we had an angle, we could use trig to figure out how long that was? But what if we just have letters? You don't want to say A plus B because that's definitely misleading because it's not 5 plus 7 is 12. If we only have letters, they had to have some way of saying it. So they would say A plus B with these bars around it, which does not really mean absolute value. It's kind of like we had bars around that other thing. What was that other thing called from our last unit? Which you just got tested on yesterday, but apparently you've forgotten. Starts with a P. Parametrics, good. What's that little thing called? It wasn't really it wasn't a resultant. It wasn't really the R, technically. The whole time it was called the modulus. And that had a Z with the little bars around it. Remember me saying that's not absolute value? That was a modulus. That was like the R. Well, this also has little bars around it. And again, usually in math, they don't do that. But these bars are technically different than absolute value bars. Okay, so that's the resulting vector. Can you add them? Let's see. Go to this slide. And do that little technique I was telling you about drawing over the top of it. That way you'll be able to move it. And I would always leave the A alone and I'd move the B. And go head to tail. Actually, make sure you put an arrow on the end because the direction of these is so important. It's a really, really big deal. And then draw the resultant and label it. Do you get how a kid would very easily have drawn this and then said that the resultant was called A plus B? Do you get why that would have been very misleading? Because it would have implied that if this was 5 and this was 8, that the total was going to be 13, and it's not. So there you go. Okay. Could I have... Okay, go ahead. Question.
Because vectors have direction.
Perfect. Yes?
Matter which way we add them. So like, is it with B instead of touching the arrow A, with the arrow B touching?
All right. Actually, I'm going to put this one back up. That was my final answer, was that green one, right? Now I'm going to take your theory and say, would it have mattered if I had done B plus A? In other words, would A plus B be the same as B plus A? Let's find out. So now this time, I'm going to leave this up here, and it's going to be hard for you to maybe to concentrate, but I'll do it in a different color here. I'll use red. Okay, and I've already got B up here, so I'm going to take A, which originally looked like this, and I'm going to grab him and move him so that it's B plus A, which is going to go right there. And do you get that the resultant for that one, I will make that with a black line, which is kind of drawn over on the other one. So do you get that's my resultant? Now my question for you is, do they have the same direction, the green one and the black one? Yes, they do. Do they have the same length? Therefore magnitude. Yes, if their magnitude and direction are the same, then they're equal. So yes, B plus A is the same as A plus B. Yes. Okay, so wherever it starts, so if I start with this, and I add one to it and I go like that, for instance, how do you know which way to go here? This way or that way? The way I like to think of it is, it's like your little brother ran ahead of you and he's not super efficient and he's like, kind of ran this way and that way, and you're now trying to get to your brother. You both start at the same spot. You're just going to go a smarter way. It's going to take you a little less time to get there than your brother took. Okay, so it always goes from, if you want me to say it this way, it goes from the tail of the first one to the head of the second one. But to me, it's a lot easier to just think of it as, I'm going to take the same, I'm going to get to the same place, I'm just going to go directly there. Okay? What would be one time where it would have been smarter to follow your brother's steps exactly? If there was a minefield, at least. Maybe your brother was skillfully avoiding, or how about this? What if it was snow? You were following behind your brother, you could like step in his tracks and you wouldn't get snow in your shoes. All right, so there's a few cases where it might be actually smarter to follow your brother, but in this case, if the goal is to get there faster, the straight line will be faster. Although they have proven in certain situations, a curve is faster than a straight line. Whoa! Somebody get out the paper towels. But that's way above our pay grade. We're going to be sticking to adding little things like this together. Would you check F, please? Make what you think the answer to F is, and I'm going to draw it real quick, and then you see if we got the same answer. Okay, so I'm going to make my B like this with a little arrow on the end, and I'm going to drag him over, and there we go. And then the resultant is this black line starting here, getting to there just a little more efficiently. And it's called A plus B with the little bars. Make sense? All right. So what happens if you add three vectors together? Well, that's probably what you'd expect. I think you'd expect this anyway. I just go from here to here. Okay, make sense? All right. What if I go from here to here, and then from here to here, and then from here back to where I started from? What does that add up to? Think about it. 0. It's the 0 vector. So if you do a vector problem where you're given more obscure things, like first you're going to travel at this blah, 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 and then you're going to travel at this angle and this distance, and then you end up adding up the whole thing, and then you get the 0 vector answer, you know what happened. You're back where you started. Exactly. Okay. So there's only one slide we skipped, which was just this one, which is pretty easy. Like, which are opposite directions? Come on. Can't name me two that are opposite directions. So pretty easy. G and C are going in opposite directions. Exactly. Do they have the same magnitude, G and C? No. Name two that would have the same magnitude. A and C do not have the same magnitude. They have the same direction. Watch your language. D and F, yes. Yeah, I know. You were just. I'm just teasing you. If you say F the wrong way, it can sound bad. And then, if we have G and U, would you agree that they're the same in some way? Same magnitude, different direction. Okay. How about parallel? If you haven't forgotten about train tracks, you kind of know what parallel is. A and C are parallel. D and F are parallel. Is there any that appear to be the exact opposite of parallel?
Yes.
F and G, yes. C and D, good. Okay, good enough. Those are perpendicular. All right, moving on. We're going to get to the homework. That's all I need to teach you. So it says homework problems day 1. Okay, so if we get into our assignment for today, if you have trouble on these, I'm going to have to move you to the other class because this is so easy. Don't overthink these. Number 1. Okay, now there's a lot of pressure, right? Number 1, classroom chair is moved from the front of the room to the back of the room. Is that like a scalar or a vector? Well, it'd be kind of handy if I told you what a scalar was, wouldn't it? Okay, a vector has magnitude and direction. Come on, just give me an idea of what do you think a scale measures? just magnitude. Okay? So the scale of something is its magnitude. It doesn't say which direction. Okay? So what do you think number 1 is? Does it have direction or not? It's got a direction, therefore it's a vector. There you go. How about a balance in your bank account? Does that have a direction? No. You could have the change in your bank account could have a direction, down or up, by putting money in or taking money out. But just the balance, no, that's not got any direction. So it's a scalar. All right, they are as easy as you think they are. On to number 5 and 6. These are flawed slightly because it should say the little vector symbol above each one of these. It's just we didn't have one of those in our capabilities when we were typing this in because, again, they don't have one. They have a array. Could have put array over all of them, but anyway. This little symbol, the half arrow thingy, the red thing there, should be on all of these. Okay, so what's the answer? Well, BA, no, that's different than AB. AB and then BC goes here and then there. So what's the resultant? AC. Don't forget when you're giving the answers to give the little half arrow symbol, the vector symbol. Okay? And one of these, yes, is the 0 vector.
Yeah.
All right, moving on to number 6. This is just asking you to, compare. Do you get that AB is not the same as BA? Do you get how they would be going in opposite directions and therefore not be the same? Even though they have the same magnitude, they wouldn't have the same direction, so they're not the same vector. AB and BA are different. Is A the same as AB? Little a, I should clarify, is little a the same as big A, big B? Yes, that is the same. All right, moving on. This one, it's actually got numbers in there. And do you remember these little compass roses? Do you remember how you can figure out if that angle's 20, then this angle right here must be 20 because those are parallel lines. If it's a compass rose, we know that that's going to be parallel to that, and therefore that's a transversal running through there. So that and that are equal angles, and therefore that right there is 20. You know what I'm saying? All right, so you can figure out the angles involved here. And if this was a right angle, you could use the Pythagorean theorem, but it's not because this is 90 and that's 20. That makes that 110. So how are you going to figure out the third side? Ooh, you've got an app for that. Law of cosines. And if you know an angle and a side across from that angle, then law of sines is really slick. Do you know this angle right off the bat anyway? No. We know the one underneath, it's 20. Okay. Do we know that angle right off the bat? No. We know this, but we don't know the side across from it. So I would say law of sines isn't going to be the easiest thing for you. Might have to be law of cosines. So do you remember it? Anyone in here? Nope. I'm going to give you a, oh, yes? Equals what? All right, so let's break it down to what we knew. Do you agree that a squared plus b squared should equal c squared if it was a right triangle? But this is our little thing that adjusts it. 2ab cosine c. And how do we know it's cosine? Well, it's called the law of cosines. And then how do you know what letters should go in here? It goes A, and then B, and then C. And that little c goes with the big C. All right, so anyway, just in case you've forgotten the law of cosines, that might be handy on this problem to figure out that last side there. All right, so that's it. That's your homework for today. I think I've explained everything that you need to know so far about vectors. Yes, sir. All the ones that were just put up there, yeah. That's still a laughably easy assignment, so I'd cut it down if I felt like it was hard. I want to keep it to around 20 minutes a night because I know you guys have a lot of other stuff to do. Okay, that's all I got for you for today. Okay, last thought I'm going to add in, and this was from a student who was questioning, was it supposed to be the little angle or the big angle? You were right. This is supposed to be the big angle right here. The big C, I should say, is the angle, and the little c. So these were a small a. I started off drawing them so big. Those are a small a and a small b, not capitals. This is a capital letter, and the capital letters for the angle. I think you all knew that that's supposed to be an angle because we can't do cosine of a side, but it is supposed to be the big C. Just clarifying point.